Welcome to the ET335 op-amp DAC lab demonstration. This is part C and it's the short version. Okay, we're back to our multi-sim and our successful project part 3. Now we're going to work on part 4. So let's disconnect our scope. And that looks good. So we're going to need another op-amp. So why don't we just copy and paste this. And we need a LM339, so let's go to analog. And we're going to need a LM, that's transistor, analog. LM339. And we'll bring that down here. Good. And we're going to need a capacitor, so let's go back to our basic. And capacitor, and we're going to use a 0.01. Still more. There we go. Okay, and we need a 1K resistor, so let's go back to our basic. Resistor, 1K. And we need a diode. 4148. No such thing. Okay, so we'll just use a regular 4002. This is it'll work. How about 4001? Okay. And we need a potentiometer. So let's go back to basics. And variable resistor. No. Potentiometer. Yes. And it needs to be a 5K. And I need two 10Ks. So let's go back to a resistor. $10K, and we need 2 of them. And that looks pretty good. So I'm going to rearrange our components here, and I'll be back. Okay, before I test this, I need to fix a couple serious errors that I made on our comparator. So there is no ground. And we're going to take the pot and put it into the inverting, and I need to take a wire off of our output. So we're going to compare our stair step with our potentiometer. Okay, let's try that now. Okay, let's try this now. So let's open up our oscilloscope, turn them on, and let's put them all at 5 for now. And let's turn on our blue channel. That's good. And let's turn on our magenta, and let's go ahead and put it at 5. And let's fix There we go, and let's fix that to 5. Good. So let's spread it out a little bit and we'll figure out what's going on here. Okay, looks like it's not going to allow me to completely do it. So let's go to single. And let's make magenta 2 and get him out of the way. Our stair step is good, and let's go ahead and lower our spike. Good. So let's really bring our, let's bring our magenta way down. Alrighty, so this is a good output. So we have our stair step coming out of our op amp. Okay, this magenta here is our comparator switching back and forth, and when it switches, it's going to produce a spike. Okay, and this spike will be limited on the back side to a small one because of our diode. And that's looking good, so that's our output. Let's demonstrate a few other things. We notice this spike here and it's pointing up to that. That is our unknown voltage. So if I change my unknown voltage, I should be able to move my spike. So let's go ahead and run it again. And when I do that, you see my spike is changing. So if I do Shift A, that spike is moving. So where this spike is and crosses, that's where our comparator is matching the two. So the yellow here would be our unknown voltage, and this is our DAC output, our analog output, and this one moves when we want to change that input. Here what I've shown is the output of our BCD 7490. So this is a BCD count, and this is the typical waveform. And so this is what we need for our troubleshooting, and this is the correct output of our device. Okay, here I've connected our oscilloscope to the output of our BCD counter and our input into the op amp. This is a virtual ground here. All of our connections, the only thing you're going to see on this side is this little spiky thing. That is the virtual ground, so we're not going to see a reading on this arrow because of that phenomenon, the virtual ground. So that is the correct look of our input into our op amp.